So good morning, good afternoon, good evening, wherever you are. Today I'm going to talk about density, which is a subtopic in Form 1, the second chapter. So we're going to learn how to measure the density of a substance using a density bottle. So here we have a density bottle which is empty. This is how it looks like for those who have never seen it. It's actually written in 50 mLs. So it can accommodate 50 milliliters of a substance, of a liquid. It can be water, it can be milk, it can be any solution. We have this part which is the stopper. The stopper is supposed to cover it that way. So first and foremost, we will go through 3 rules of handling a density bottle. Number 1 is you hold it by the neck. This is how you handle the density bottle, and not this way. Because when you do this, you are going to increase the temperature of the bottle, and therefore it will expand, giving you the wrong impression of the volume. So hold the bottle like that so that you prevent expansion. Number 2 is you ensure that as you pour the liquid inside the bottle, there are no bubbles which can be seen. Here I have a liquid inside the bottle. As you can see, there are very minimal bubbles there. So this is the way it's supposed to be done. You pour the liquid gently inside so that no bubbles can be seen. Number 3 is, number 2, we said avoid bubbles in the bottle. Number 3, and the last one, is after you pour the liquid that way, take the stopper, cover. Of course, you're going to see some spillage. As you can see, some drops are coming out. Those drops are not supposed to be part and parcel of the measurement that we expect. So you need to wipe it. You can take a piece of cloth or tissue paper, then wipe it clean. The bottle should actually be dry that way. So the mass that I'm going to measure is the correct mass which is expected. But if we have overflow, then we're going to have wrong impression of the mass. We will have excess mass. So point number 3 is wipe the bottle clean for accuracy of mass. So those are the 3 precautions that we take care of. Now, to start with, we're going to measure the mass of the bottle first. So the procedure, this is the procedure. Actually, the objective of this experiment is determining the density of salt solution. So with me here, I have some salt. Then I'm going to mix it with water. Then use this density bottle to determine the density of salt solution. So step number 1 is you measure the mass of the bottle alone. Mass of the bottle alone. So you will take an empty bottle and measure. You're going to record some measurement there. After that, you're going to now put water first. This is pure water. We know the density of water is 1,000. So this is pure water, 1,000 kilograms for every meter cubic. So pour water inside, cover with a stopper, that way. Wipe in case we have any spillage, then you measure. So that is it. So as you can see, the mass of an empty bottle, of course the bottle must have the stopper, it's part of the measurement. The mass is 19.8 grams. Remove the mass, remove the bottle. Now fill the bottle with water. You can see it's full of water. Measure the mass. You find that it's 67.0 grams. Now the next thing is salt solution. Salt solution, so you have to take an empty bottle, then fill it with salt solution. So we're going to take some salt, then mix it with water. Mix by stirring. Make sure you mix to obtain a very concentrated salt solution. I think that's all. After that, you will now remove the water from this bottle. Remove the water from the bottle, then put this salt solution inside. So this is now salt solution filled in the bottle. Cover it. Make sure it's properly covered. Take a piece of cloth or tissue paper, wipe it, just like we did for water. This is to avoid excess measurement of mass. Now it's clean. Now measure the mass. As you can see, the mass is 70.3 grams. So from the data that we have obtained, we need to find the density of salt solution. Now we have the mass of empty bottle. Mass of empty bottle, we found 19.8 grams. Then mass of bottle plus water. Mass of bottle plus water came to 67.0 grams. Then mass of salt solution came to 70.3 grams. So what you do here, you need to find mass of water alone. We shall take bottle plus water minus the bottle alone. Then mass of the salt solution alone, we shall take bottle plus the salt solution minus the bottle. Now, why are we getting water alone? It is because we know the density of water. The density of water will help us to know what is the capacity of the density bottle, because we know its density. So once we know the capacity of this water is the same capacity that we use for salt solution, because we never changed the bottle, it's the same. So 47.2, and this other one will give us 70.3 minus 19.8. It gives us 50.5 grams. Now, volume of the bottle will be mass of water, which is 47.2, divided by density. This is grams per centimeters cubic, which gives 7.2 centimeters cubic. So this is the volume of that bottle. Density of salt solution will now be mass of salt solution divided by volume of salt solution. So based on the values we have, we now take the mass of salt solution, which was 50.5 grams, over volume, which is 47.2 centimeters cubic. And the answer becomes 1.07 grams per cubic centimeter. So this is the density of salt solution. I repeat again, just to summarize the lesson. The reason why we use water is to obtain the volume of that bottle. Then we can use the same volume as volume of the salt solution, or whichever liquid that you've been given, because we are using the same density bottle, so volume doesn't change. Then substitute here, get the answer. Thank you for listening.